Let's break down the core idea behind this paper. Transformers are SSMs from Princeton and CMU. Two rival architectures. Transformers, powerful, but they choke on long sequences. And Mamba, a state space model that's blazing fast and light. For a year, they felt like opposites. This paper drops the twist. They're secretly the same math. And once you see that, you can make Mamba-2 to 8 times faster. Here's the tension. Attention is a genius that rereads the entire conversation for every new word. Brilliant recall, but the work explodes as the square of the length. A state space model is the opposite. It keeps one running summary, a fixed-size state, and updates it token by token. Linear, cheap, constant memory, but harder to train fast on a GPU. Two philosophies that never talk to each other. Let's actually watch the state space model work. It carries a hidden state. Think of it as a running ledger. Each token comes in, gets scaled by a matrix B, and added to the ledger. The ledger itself decays a little each step by a factor A. And to read an output, you project it out with C. One token, one small update. No looking back. Everything you know is already folded into that state. Now unroll that recurrence all the way and ask, what single matrix turns the whole input sequence into the whole output? Because the state just accumulates and decays, output T depends on input S through the decays stacked between them. A times A times A. Lay all those out, and you get one big lower triangular matrix. The future can't see the past. That's the triangle. And this is the punchline. That matrix has a name. It's semi-separable. Every entry is CT times a chain of decays times BS. But look at its shape. A lower triangular matrix that mixes tokens by a learned weight. That's exactly what a masked attention matrix is. The state space model and attention aren't cousins. They're the same object, written two different ways. The authors say it straight. Which means you get to choose how to compute it. Read the matrix as attention. A big quadratic grid, every token against every token. Slow, but it runs beautifully in parallel on a GPU's tensor cores. Or run it as the recurrence. Linear, tiny memory, but sequential. Same answer. One's fast to train, one's fast to run. Why not both? That's the SSD algorithm, and it's the whole trick. Chop the sequence into chunks. Inside each chunk, compute it the quadratic, attention way, small blocks, so the square is cheap and the tensor cores scream. Between chunks, hand forward just the compressed state, the linear, recurrent way. Diagonal blocks quadratic, everything off diagonal handled by one little state passed along. You pay the quadratic cost only on tiny blocks and stay linear overall. Wrap that into a layer and you get Mamba-2. Because it's now attention-shaped, all the transformer tricks transfer, multiple heads, a much bigger state, clean tensor parallelism across GPUs. The selective scan that made the original Mamba awkward on hardware is gone. Replaced by fat matrix multiplies the GPU already loves. And the payoff, in their words. If two things you thought were different turning out to be the same thing is the kind of plot twist you're here for. Like, subscribe, and pass it to the friend who argues Transformers versus Mamba like it's a sports rivalry. Does it hold up? Mamba-2 matches or beats a Transformer at the same size on language modeling, trains 2 to 8 times faster than the original Mamba, and, because the state is bigger, it's genuinely better at the needle in a haystack. Recall that small state space models used to fumble. So the recipe, a state space model is a recurrence. Unroll it, and it's a structured triangular matrix. That matrix is a masked attention matrix, the duality. So compute it chunkwise, quadratic inside chunks, linear between them, wrap it in multiple heads, and you've got Mamba-2. Attention's hardware, a state space model scaling. The one-line version. Attention and state space models are the same matrix in disguise. Recognize that. Compute it chunk by chunk to grab the best of both, and Mamba gets 2 to 8 times faster without giving anything up. It makes you wonder what other rival ideas in machine learning are just one change of coordinates apart, waiting for someone to write the matrix down. That's my read. Tell me yours. Until next time.